Good morning, students. This is Mrs. Hovey on a Thursday, April 23rd. Today we're going to talk about factorials, which, if you remember the fundamental counting principle, quick review, fundamental counting principle, there were four possible numbers, so 4 could go here, 4 could go here, and 4 could go there. You could have a number in each spot. With a factorial, it's a little bit different. Here's the definition of factorial. I'm going to move this out here a little bit, so sorry about all that. Factorial is n with an exclamation point. It's read as n factorial. It's basically the product, which means you're going to multiply, of all positive integers beginning with n and counting backwards to 1. So here's our example, 5 factorial. We're going to start with 5, and we're going to multiply by every number, starting with 5, going back all the way down to 1. 5 times 4 times 3 times 2 times 1. And if you do this, 5 times 4 is 20, times 3 is 60, times 2 is 120, times 1, our answer is 120. So let's do a word problem that we know is kind of going to use the factorial. Zach and Kurt are going to an amusement park. They cannot decide in which order to ride the 7 roller coasters in the park. How many different orders can they ride all? This should be of the roller coasters if they ride each one only once. So there's 7 roller coasters. They're going to ride them all one time. So if they start, this is going to be 7 factorial. They start with 1 roller coaster. They did that. Now there's only 6 left to ride. Now there's only 5 left, 4 left, 3 left, 2 left, and only 1 left. So if you put this into your calculator, 7 times 6 times 5 times 4 times 3 times 2 times 1, you are going to get 5,040 different orders that they have. This is how many different ways that they could ride those 7 roller coasters. On your scientific calculators, there is a way to do a factorial. I just don't have a calculator with me. You would have to look. It's probably underneath probability someplace. But it's really not that bad to do 7 times 6 times 5 times 4 times 3 times 2 times 1. So let's try a little bit smaller one. Many of you have codes for your garage door openers. John needs a 4-digit code for his garage door opener. If a number cannot be repeated, how many possible codes are there? He needs a 4-digit code, so 1, 2, 3, 4. Here's where we're going to use a partial factorial, okay? So 4-digit code, he has 10 possible numbers to go in the first spot, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. But he cannot be repeated, so only 9 possible numbers there, only 8, only 7. So we're going to do that. We're going to do 10 times 9 times 8 times 7. So we're going to multiply those together, and that gives us 5,040, just like the last one. So there's that many possible codes. It's a partial factorial. We can't say 10 factorial because it doesn't keep on going down that way, but we know we're just using the first 4. So let's just do regular factorials. 3 factorial would be 3 times 2 times 1. I bet you can figure it out. It would be 6. 6 factorial. Again, start with 6. 5, 4, 3, 2, 1. Multiply all the way through. You get 720. 9 factorial is a big one. 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. I'll give you a moment. Put it into your calculator. You get a whopping 362,880. These are going to be the factorials that you're going to be doing in your assignment today. So don't worry about the partial factorials that we did on the previous page. Just worry about regular factorials. So your homework. go to Schoology, do the check-in form. Obviously, you're watching the Factorial video. Then you're going to do IXL.com skill WTX. And it's just on Factorials, just like we did on the previous page. That's your assignment for today. On Tuesday, I believe, is the next time we have our cycle starting. We're going to start another project. Hope you have a great day. No set Google Meets today, but if you do have questions, please message me. I'm going to try and get the gradebook up to date this weekend, including your projects, both your geometry projects and your number posters. So hopefully we'll see something going in the gradebook. Look for missing assignments. Otherwise, have a great day, and if you need help, let me know.